Today's topic is dividing monomials. We're going to start with a quick review on simplifying fractions. We'll be starting with the example 21 divided by 7. Hopefully you were taught to break down both the numerator and the denominator to the best of your ability. Oh, there we go. All right, 21 can be broken down into 3 times 7, and 7's prime, so you cannot break that down. If we follow proper mathematical processes, if we use the associative property, we can regroup this into 3 times 7 divided by 7. We know 7 divided by 7 is 1, and using the multiplicative identity, 3 times 1 gives us 3. Now, I'm sure most of you were not taught this lengthy process, but rather taught a shortcut. You probably still started by breaking things down. So the 21 was 3 times 7 over 7. Then you look for things that were the same in the numerator and the denominator. In this case, both the 7s were the same, so you cross them off. At this point, you wrote down whatever was left, which was 3. Note we get equivalent expressions. We just have to be careful that canceling is not a proper mathematical process. When we cancel things out, what we are really doing is we are eliminating those things that when simplified would give us 1. Our next example is 15 divided by 35. If we break the 15 down, we get 3 times 5. If we break the 35 down, we get 5 times 7. If we use the commutative property here, we can rearrange the 3 times 5 into 5 times 3. If we regroup things, we got 5 over 5 and 3 over 7. 5 divided by 5 is 1. Gets us to a point where we can use the multiplicative identity, and we end up with 3/7 for the answer. Once again, most people do not go through the lengthy process, but they use the shortcut. It would still break the 15 down into 3 times 5, the 35 down into 5 times 7, but if we look for the things that are the same in the numerator and the denominator, in this case the 5s, we would cancel those out, and that would leave us the 3 over 7. Next, we're going to move on to examples including variables. It's important to note that all variables in the denominator cannot equal 0, can't divide by 0. So most of the time when you look at your directions, they will say variables in the denominator will not be equal to 0. For our first example, what we're going to look at is the fact that we still are going to do the processes the same way. You still want to break down, or I say expand, the numerator and the denominator to the best of your ability. 9 can be broken down into 3 times 3. X squared is a mathematical way of writing x times x. X cubed is a mathematical way of saying y times y times y. At this point, if we're going to use the shortcut, you want to look for things that would equal 1 if you divided. So 3 over 3 would give us a 1, x over x would give us a 1, y over y would give us 1. At this point, if we write down what remains, it turns out there's nothing on the bottom. If we write this out using exponents, we'd have 3xy squared. For our next example, once again, you want to expand whenever possible. So 6 is 2 times 3. X cubed, we can write out as x times x times x. And the y squared, y times y. In this case, the 21 can be broken down into 3 times 7. We got the x and the y. Once again, you would look for what you can quote-unquote cancel out, or basically what simplifies to give you 1. We got the 3's. We can do an x, and we can do a y. In this case, we're left with a 2, x, x, and y in the numerator, 7 in the denominator. And if we rewrite it using our exponents, we get 2x squared y over 7. In our next example, this time the 17 is prime, so it does not break down. If we expand the x's and the y's, Our numerator is going to look like that. 34 does break down. This time we have an exponent in the denominator, so we're going to have to expand that. And at this point, we can look for things that would simplify to give us 1. So the 17 over 17, we can do those x's. We can do another pair of x's, top and bottom. And we got a pair of y's that can be eliminated. If we look at what's left, we got the 2 y's on the top. We got a 2 and the x on the bottom. We're writing using our exponents. We got y squared over 2x. For our last example, I've included a z. So if we expand the numerator, 14 breaks down into 2 times 7. And by the way, that funky line through the z is because my handwriting's so bad, I don't want the z's to be confused with the 2. On the bottom, if we expand it, we got the 2 times x times y. If we look for things that match top and bottom, we got 2's, we got an x, we got a y. So if we look at what's left, we got 7, y, and z in the numerator, and an x in the denominator. I hope you found this somewhat helpful, and I wish you good luck in your mathematical endeavors.